you're still unfamiliar with it, well, then we're going to continue along with the lesson. On Monday, we went over how to basically looking at the Scratch environment, understanding the canvas, understanding the script block system, the coding area, costumes, sounds, things like that, just sort of all of the different features of it. And that was our lesson. Now, today we're going to continue along with that. We're going to introduce some more things like how to change costumes and how to make more complex programs in Scratch and things like that. We will potentially be doing this next week, though it's possible we might move directly on to, or do we know? Who knows? We'll sort of gauge how everything feels at the end of the lesson today, and then we'll try and make an appropriate decision based on that. Anyway, I'm going to go ahead and open up Scratch right now. I hope everybody's doing well, by the way. Good old Untitled 6. This will be my program. Yes, I did. Was it the one where you had to dodge the arrows? Yeah, check that out. It was like a little bit after you left. That was pretty great. Yeah. Okay. So like I said, we went over the different parts of Scratch. We went over scripts and costumes and sounds and such. We created a really simple program where the cat just sort of floated to the right, and that was it. And then we embedded it within a loop, so he floated to the right and said hello world a little bit more often. But that was about as far as we'd gotten. Today we're going to spend some time messing around with costumes. We also went over comments. Comments are good for keeping track of your code. But yeah, today we're gonna go over costumes. So as it stands right now, we can make the cat move. Oops. We can make the cat move. However, it's not animated in any way. He just kind of slides to the right. We can also reset its position and do all that good stuff. But again, there's no real sort of dynamism to it. You know, it doesn't look like he's walking. It doesn't really do much. So what we're going to do is we're going to experiment with costumes in order to make this look a little bit more, I guess, I say realistic, a little bit more believable. So what I'm going to do is, just like before, I'm going to go ahead and embed my program inside of a loop. We're just going to have it repeat 10 times just so we know exactly how far he's going to move and everything like that. And then what we're going to do is we're going to have him wait a little bit. I believe that's should be here. Yep, here we go. And then we're going to go to the next costume. and that's it. It's just really super simple. But it looks like, for the most part, like he's just sort of doing like a weird thriller shuffle walk kind of a thing. But it's definitely an improvement over what we had before. Now, there's also the bit where he sort of slides forward before and after um, we move, or change costumes, excuse me. But that could potentially be fixed by throwing our next costume in front of the change X. So now he's only moving forward when his costume changes. And we can watch it again. But see, that's another part of these. That's another sort of purpose of this is figuring out what we can do in order to make this work better. Uh, given what we're provided with here, that works well enough, except again, you run into the strange issue where he slides before and after he changes costume. And that's not exactly ideal. So what would we do in that situation? This is, in essence, a bug. So we would mess around with our program flow in order to fix that. So that was sort of an aside, but basically the point I'm getting at is it's good to also be thinking about how everything in your program is structured and ordered, and Scratch is an excellent thing for that because you're focusing on the flow of your program as opposed to whether or not your syntax is correct. Anyway, I just sort of glossed over the fact that this next costume thing exists, and I didn't really talk about how it works in relation to everything else. Well, again, we've got costumes. Costumes are different sort of sprites, I guess, for a given entity. Now, I know that's probably weird because I'm mixing up my nomenclature right now, or my names. Um, but yeah, at that point, it's all a matter of semantics. A sprite, in the strictest sense of the term, is a graphical entity. Um, it's something that exists on the screen that is rendered by the program. So that can be a single frame, hence, again, sprite sheets. So a sprite sheet can be a bunch of different sprites all placed together. So that you can have like a bunch of animations for a single character, and then from there the character itself would be the entity. It would be the elements in the game. It would be an NPC or the player character or something like that. Um, that's mostly where I was going with that. In this case, the naming for Scratch is a little bit different. The sprite is the entity, and the costumes are the different sprites. But it really all comes down to how everything is named anyway. Anyway, different sprites for the same entity. We got one where he's kind of skipping and one where he's got like a jaunty stride. And when we say next costume, all we're doing is we're moving down the list. So if we wanted to, we could, add a new, what if we just duplicated it? Yeah, there we go. We'll just duplicate these and we'll rotate them. We'll rotate them back and we'll rotate them upside down. Oh wait, whoops. And we'll duplicate another one. You can just right click on it and select duplicate. I mean, not entirely sure why your right click isn't working. Right, I remember that. Let me see. Are you using Firefox, Jacob? Hmm. We'll get to that in a moment, Aiden. You can try using shift click, Jacob. Does that end up working for you? Excellent. All right, cool. And then Aiden, for rotation, what I'm doing is I'm flipping them actually. In the upper right-hand corner, there should be 4 small buttons. One of them is grayed out. That one's crop. And you've got 2 flip buttons, and then you got one that says set costume center. I've been using the flipping buttons. Yeah, no problem. Let's see if we can't order this. So again, just to prove a point here, we've got forward, back, upside down, forward, upside down, back, and then we'll call this like the neutral position, I guess. If we're to run this, you can see he goes forward, then he goes back, then he goes upside down, forward, upside down, back, neutral position, forward, back, upside down, forward, upside down, back, neutral position. So next costume simply means we're moving down to the next costume in the list. And that's it. That's all it is. That is literally all it is. Just moving down to the next costume in the list. Alternatively, we can also move to a specific costume. Switch costume to costume 4, maybe, or costume 1, or costume 3, or costume 5, blah, 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 blah. You get the idea. In essence, we can, instead of running through the list like this, we can switch to a specific one in case we have several different modes that we actually, make use of. Like if we could keep track of all of a character's animations inside of their costumes list. So there could be a walking animation, there could be a jumping animation, there could be a shooting animation, things like that. And then you can, when you queue one of those animations up, you could jump to a specific costume, have it run through like the next maybe 5, and then flip back to the first costume in that animation. If that makes any sense. But yeah, so now what we've done is we've combined costumes with the knowledge that we already have in order to improve further upon our program, if I guess you would call what I made improvements. I guess it's sort of an improvement. He's doing flips. He's doing flips. Another point, we can also use decimal points in our waiting time, because Scratch asks for the amount of time we want to wait in seconds. However, computers will record the amount of time that's passed in thousandths of a second. So Scratch has the capability to take advantage of that. We can say wait 1 second, we can say wait 2 seconds, we can say wait 20 seconds. We can say wait 200 seconds. We can wait 2,000 seconds. Although I don't recommend it. We could. But we can also wait fractions of a second. We can wait 0.2 seconds. And Scratch will understand that. So we can go like, now it's much faster as he dances and jiggles his way to victory. Drag him back. Come back. We'll also reset his X and Y position to 0 at the end. Because I do change his X and Y, or I did change his X and Y manually. So now, yeah, he does his thing. And with that, I mean, you guys understand how to change costumes now. And with changing costumes, you can include animations in your stuff. Now, remember what I was saying about vector art? Nice. Excellent. There's this thing we can do with vector art that's pretty cool. And that is we can change the shape of something with vector art. So instead of having him do this walk, we can reshape his leg. Whoops. So that he is, I don't know, sprinting or something. I'm not a very good artist. Well, first off, you will need to be not in the cursor mode, but you'll need to be in the next one down, which is labeled reshape. Once you've selected that, you should be able to yeah, for sure. So with this, we can actually mess around with this and make more believable running animations once we we have fixed the horrifying misshapen foot. Yeah, right? We'll flip him back, duplicate him. Yeah, this cat's seen better days. But we're getting there. We're making this look better and better. Whoops. Gotta go fast. Sanic cat. And you can see how much work this is because um, I haven't even worried about moving his arms yet, so that's going to look super weird and awkward. But the idea is there. So if we're to test this out, let me go ahead and delete the upside down costume. It's kind of looking like he's running now. Like that was a fair amount of work, but it's getting there. Now we just have to have an animation that makes him go into supersonic. And maybe have his arms move in addition. Well, thank you. You too are capable of making animations that look this um, intentional. The problem is that there's a lot of frames devoted to the back leg moving forward, and like one frame devoted to the front leg moving backward, and it just doesn't translate as well. But anyway, again, that's one of the benefits of vector art, and that's part of the reason why they included vector art here, because A, it's easier to use and smaller, and B, you guys are more than welcome to manipulate the nodes on it in order to give him all kinds of different poses and stuff like that. In addition, we can do that, although I don't know why we'd want to. But yeah, we can totally recolor. We can recolor this cat if we wanted to. Turn him all crazy red for no particular reason. And so we would see that in the animation. Yep, there's one part where he turns red. We could turn him evil. You get the idea. Essentially, there is a lot you can do with the costumes feature in order to give your characters like new life. We can also include new sprites, and actually, um, Scratch has a whole bunch of sprites in its sprite library, like a lot of sprites, a lot. Earth, elephant, fire hydrant, fish, ghost, electric guitar, Jody, whoever that is, parrot, Pico, Sam, squirrel. There's a squirrel. We're going to include the squirrel. The squirrel is now a part of our scratch. Oh, there we go. My cursor disappeared for a second. And then here's the important thing, though. Where did our code go? Well, I'll tell you. Let's click on the sprite again. It appeared here. So essentially, code in Scratch is tied to sprites. It's tied to entities in your canvas. So we can have code tied to sprites. We can have code, I believe, tied to backdrops, if I'm not mistaken. We can have code tied to all kinds of stuff. So we can have two separate things happening at once if we really wanted to. So we'll move him down to change y by negative 100. So if we run that, okay. And then we'll change that to, and you see why I did that. That was mostly just because this go to X and Y defaults to their current position. So if I move the squirrel to a position that I want him to be in, then use the go to X and Y, I can ensure that he returns to the same position each time. And then, of course, I'm sorry, I'm doing incredibly important things. See now, our squirrel slowly moves up from the bottom. Let's go ahead and wait 0.2 seconds. That's too far. Still too far. I got to make sure this looks impeccable. Yeah, there is a flying cat sprite. Exactly. You are totally correct. Which is it's pretty awesome. So anyway, as you can see, we in my incredibly competent program, we have them do two separate things, and the way we can achieve that is by each of them having their own set of code built in. So the squirrel has his own set of code, and the cat has his own set of code, and then we run them. It runs both of them at the same time. Now keep in mind, it runs both of them at the same time because I gave them both the when green flag clicked. If I didn't give the squirrel the when green flag clicked block, he wouldn't do anything when I click the green flag. In fact, because we don't attach it to anything else, he wouldn't actually do anything at all if we ran the program. But as it stands right now, because we attached that, we now have a squirrel creeping on you. In addition to new sprites, we can also add backdrops. Backdrops are just settings, scenes. I mean, it's pretty self-explanatory. So we'll add city with water, and now we've got Sanic cat running across the top of the water, and Godzilla squirrel emerges to destroy the city. Now, here's the other thing. We can attach scripts to the stage, so the backdrop. We can keep track of all of our backdrops so we can switch between them, have multiple different backdrops. And we can attach sounds to it as well, just like we can with any of our sprites. So here, there's a pop sound already built in. With the squirrel, it's got a meow. With the cat, it's also got a meow. Kind of bizarre, but okay. But yeah, so with all of these things together, you can actually increase the complexity of whatever you're working on pretty significantly. You can have multiple backdrops, which can be different levels. You can have the backdrops have their own code that reset everything to like, their starting positions, um, and then you can have them pull up code on each of the sprites so that they do their thing, that kind of stuff. In addition, you can also modify backdrops just like you can costumes. So now that we've done all that and I've rambled for as long as I have, let's actually get into making our first game. I'm going to delete, well, I'm going to move our backdrop back to backdrop 1. I'm actually going to delete our old backdrop. I'm going to delete the cat sprite, and I'm going to delete the squirrel sprite. So now we have an entirely empty canvas. That's what we want because we're actually going to add some stuff in. First off, we're going to add in, let's do just the regular ball. How to change from background to sprite? Okay, so that's because you have the background selected, the backdrop selected. You want to click on one of the sprites in order to be able to go back to costumes. But you just do it by clicking on it. So now we've got our ball sprite. We're going to include a, is it here? Yes, it's here. Trampoline sprite. So now we got ball and trampoline. Move the trampoline down to the bottom. And that way we have sort of like a bottom area. Now we're going to do something with the trampoline. We're going to have code on it that's going to run as soon as the green flag is clicked. And remember, this is code that runs on just the trampoline because we have the trampoline selected right now. We're going to put this inside of a forever loop because we want the trampoline to do this forever. And we're going to set the X to something. What do you think we're going to set the X to? If we want to control this to the mouse with the mouse, what do you think we're going to set the X to? Well, we want to probably set it to the X position of the mouse, right? So that actually exists in sensing. Sensing contains a whole bunch of stuff that basically looks for input. So touching mouse pointer, touching color, color is touching another color, distance to mouse pointer, ask what's your name. Well, that's sort of like an input. If a certain key is pressed, if the mouse button is down, mouse X, mouse Y, loudness, video, turn video on, set video transparency timers, days since 2000. Trampoline sprite is in the sprite library. So if you just click on new sprite from library, which is the first little thing there, trampoline will be down a ways, but it's all alphabetically listed as well. But yeah, so okay. We're going to set X to mouse X. And we can do that just by dragging it inside of this little text box area. Instead of it being 0, if we drag mouse X into there, it looks like it highlights. That's because we can just slot it right in there. So now X is going to be set to whatever mouse X is. If we run it, we can, in fact, verify that. We'll wiggle the mouse around, and the trampoline's going to follow it. Pretty cool, right? So far, so good. We have the beginnings of a game. Now we're going to have the ball move around and bounce off of the trampoline, presumably. So I'm going to go ahead and I'm going to set up the ball so that it starts moving. Put it up here. And again, this is something that's going to start as soon as we start the program. We're going to have it well, actually, I did that wrong. We're not going to have a repeat 10. We're going to have a repeat forever. And I believe there's if on edge bounce. Okay. So under motion, there's if on edge bounce. And if on edge bounce will, well, obviously will change the direction of the ball. It will make sure that it doesn't go off of the edge of the screen and it bounces somewhere. And then we can set it to move 10 steps. 10 steps is just 10 steps forward in whatever direction it's facing. And we can't really tell what direction it's facing right now because the ball is a circle. So we can't really tell if there's a forward or a back. But let's go ahead and just see if we hit the green button, the green flag. As you can see, it was actually facing almost directly forward, and now it's just kind of bouncing back and forth. But I guess that's not really surprising, right? Because we just dragged it out of the sprite library and didn't do anything with it. So it's not really surprising that the ball, was facing directly to the right. So I'm going to go ahead and hit the stop sign. As you can see, it still hangs out in the same spot wherever you stop it. So we probably want to have like a reset as well. So we'll go ahead and do that. Go to X and Y. Let's say 0 and 0. So now, anytime we start up the program, it's going to go to 0, 0, and it's going to, the trampoline won't go to mouse X. We'll check your code to see if it's set up like mine. It's got to be inside of a forever loop because it always has to be checking to make sure that it is at mouse X position. Did that help at all? Okay, excellent. All right. So the other thing we see here is that the ball just goes left and right. It just does that. That's boring. So what we can do is we can have it move in a specific direction. Point in a specific direction. Let's say point in direction 45. So now here's what we have. We go to 0, 0, we point in direction 45, which probably means up here, and then we have it move 10 steps, and if it's on the edge, it'll bounce. So let's test it out. Hey, look at that. Now it's bouncing around everywhere. Goes through our trampoline, but it bounces around everywhere. Cool. So far, so good, right? So now we need to check and see if it can bounce when it touches the trampoline. So now we can start using if statements. If statements are fun. This is where a lot of the interesting stuff happens. So as you can see, the structure of it is if, and then we have this weird shape, then. If statements are a big part of programming. So are loops, so are, a lot of things. But if statements you'll be using a lot of as well. If statements essentially direct the flow of program code to at least be able to react to input. What do I mean by that? Well, let's say we created a program, we had no if statements in it. Every time we ran it, it did the same thing every single time forever and ever and ever. Sometimes you want that to happen. Most of the time, you don't, though. Most of the time, you want it to respond to some sort of input or some sort of change in the computer environment. Let's say, for instance, let's pretend that your routine for getting ready in the morning is a program. Every morning you got up, had breakfast, put on clothes, probably took a shower first, put on clothes, and then went out the door. And this was a program, and even down to what clothes you put on. You put on the same blue shirt, you put on the same pants, you put on the same shoes every time you put on clothes. You always showered for, 15 minutes. You always had cereal for breakfast. That would be like a program without if statements, because the world can be different, right? It could be raining outside. There could be no cereal in the house. Maybe it's cold and you want to take a longer shower. I don't know. So in that case, you might have something like, if it's raining, then wear a jacket. If there's no cereal, then have, I don't know, a banana, oatmeal, something. If statements allow you to basically have the program ask itself a question. What is this? Is X5 or whatever? And then either execute that code or skip it. So in this case, we're going to grab something from the sensing area. We're going to say touching trampoline. So if touching trampoline, then we're going to, I believe, point, yeah, okay. Point in direction 0. And we're going to turn 15 degrees. Turn clockwise 15 degrees. So now, this is asking if the ball sprite is touching the trampoline sprite. If it is, then it's going to execute the stuff inside of this if block. If not, it's going to skip it and move on to the next thing. So as we can see here, hey, look at that. And then as soon as it touches the trampoline, it starts going up. If it doesn't, it goes all the way down before it, decides to head up in the different, towards the top of the screen. So it bounces across the bottom. So now we've got a ball that moves around, bounces off all of the edges, and bounces off the trampoline. We still don't have a lose condition, so, it's arguable as to whether or not this is actually a game, but we've got something here now. We can control the trampoline. We can indirectly control the ball. We've got something that kind of resembles a game. And I stopped it right before it touched the bottom there. Perfect timing. Boop. Okay. So yeah, what is an if-then statement? If-then statements tell your program to execute a certain section of code only if the expression evaluates to be true. If the expression evaluates to false, the code jumps to the end of the if-then statement. That's sort of the more computer sciencey way to put it. But yeah, basically, if this statement here is true, let me go ahead and circle it. If this statement here is true, then run the stuff in here. We could actually, yeah, we could. That's an excellent question. Could you have it so that it sometimes bounces 15 degrees right, or does it always have to go to the left? Uh, in this case, it always bounces to the right, but it is possible to do this. And I'll show you guys how to do that right now, in fact. So we can always have it shoot off in a random direction and stuff like that. So what I'm going to do is I'm going to get rid of this turn 15 degrees. And I'm going to keep this point in direction. I'm going to go over here to operators. You see this one right here, pick random 1 to 10? Well, that pick random 1 to 10, it's just as it sounds. You pick a random number from 1 to 10. But we can also change that. We can say, let's say, point in direction, pick random. Trying to think of what the best way to do this is. Can you do negative 10? Okay, well, let's give it a try then. Negative 10 to 10. Because I think negative 10 is... Oh no, it's not. Okay, excellent. So yeah, if we try that out, so as you can see, sometimes it bounces to the left, sometimes it goes straight up, sometimes it bounces to the right. Just by doing that. And in fact, we could do the same thing up here. Point in direction, stick a random number in here from negative 45 to 45. So now anytime it starts up, sometimes it'll shoot off to the right, sometimes it'll shoot off to the left, sometimes it'll go straight up. But each time the ball moves in a different direction. Well, it's not guaranteed to move in a different direction, but the odds are very good that it's not going to shoot off in the same direction that it did last time. That's another power of computers, is the ability to generate these numbers, which can, add randomness to it. These numbers aren't, strictly speaking, actually random, because that's something that's not actually a possibility. But they can be random enough to feel truly random to us as users. And that's sort of an interesting story, but that's an explanation for another time. At any rate, I'm going to do the poll questions now, and we'll do the question and answer time like we always do. And if you don't have any questions, you're more than welcome to head out after the poll questions. But for now, let's go ahead and send the first one out. I just want to make